Hello, Honors Algebra students. Mr. Lawrence here. You asked for a review video. I'm going to give it to you. I'm going to give it to you in two parts because I think this video might get a little bit long. First part will be all about equation solving. So let's get down to it. All right, some basic equations here. Number one is a simple two-step equation. Remember, you got to listen to Saddam. Saddam will tell you to undo subtraction and addition before you undo division and multiplication. So I'm going to get rid of this 5. Now some of you will make a common mistake and you'll go plus 5 because you'll see this minus here. Remember, this negative belongs to the 2. It does not belong to the 5. That is a positive 5 there. If you need to highlight, okay? But that's a positive 5 there. So since that's a positive 5, I'm not going to add 5 to both sides. I'm going to subtract 5 to both sides. Hey, by the way, if you're just passively watching us, you're not going to do as well as if you pause the video and try them on your own. You can see these 4 problems. That is a 7 down there. Try these 4 problems on your own and then see if your solutions match mine. Now, you might take a different approach, but as long as we get the same answer, all is good. All right, so the 5's have canceled. I've got a negative 2x. Don't lose that negative. And that's going to equal 2. All right, I'm going to divide both sides by negative 2 because the negative 2 and the x are attached by multiplication. Divide by negative 2, x is going to equal negative 1. Now I can check my work. I can go 5 minus 2 times negative 1 and see what that equals. If it equals 7, I'm in business. Now, notice I have a negative 2 there, and I'm multiplying by negative 1. I just substituted negative 1 in place of x. So let's do the multiplication first. Well, I'm going to get 5 plus 2. How did I get plus 2? Because minus 2 times negative 1 is a positive 2. 5 plus 2, 7. I did it correctly. All right, let's come up here to problem number 2. Now, problem number 2, there are a lot of different ways to do it. I would like to multiply to get rid of my denominators first. That's how I would do it. I think it'll be a lot easier. And then it'll look like a normal two-step equation. And I will listen to Saddam. So, the question is, what number am I going to multiply by? Well, I need the smallest number of 3, 4, and 5. I need the least common multiple. Well, you could count by 5s until you get one. 5, 10, 15, 20, 25, 25, 30, 35, 40. Still haven't found it. 45, 50, 55, 60. Hey, 60. 60 works. 3 goes into 60 evenly. 4 goes into 60 evenly. I'm going to multiply by 60 over 1. And I'm going to multiply. I'm going to show this a little different. I am distributing, but I'm going to show it like this so that nobody gets confused. All right, 60 over 1 and then 60 over 1. I have to use a fraction in all 3 places because all 3 terms are fractions. So when I do that, 3 is going to go into 60 20 times. So this will be 20 times 1. It's 20. All right, 5 will go into 60 12 times, I believe. So I have a negative 12x. And then over here, I'll have a 15 because 1 times 15 is 15. Now remember, if this wasn't a 1, I would have to multiply, right? Okay, so now it looks just like the problem I did. So I'm going to subtract 20, and I'm going to get that negative 12x equals negative 5. I'm going to divide by negative 12, divide by negative 12. X is going to equal positive 5/12. Yeah, I forgot to put that negative on the division, but I did say it when I did it. So, okay, so if you haven't tried problems 3 and 4, go ahead, try them, and even 5 here. Go ahead, pause the video, see what you can do with it. I'm going to move this down and give myself some room to work. All right, here comes my solution for 3. First thing I'm going to do is get rid of this denominator. How do I get rid of the denominator? I multiply. I multiply by a fraction. I don't do this because 7 times 7 does not cancel out. That would be foolish to try and do it that way. All right, so I have to multiply by 7 over here. Since the 6 is not a fraction, I don't need the 7 written as a fraction. All right, let's see. The 7s are going to cancel, and I'm going to be left with a 5x minus 1 and a 42. Add 1 to each side, and we're going to get 5x equals 43. I'm going to divide by 5, divide by 5. X is going to equal 43/5. Or if you'd like to go mixed number, it looks like 5 is going into 48 times. It's 3 short of 43, and there's 5 left over. Either one is acceptable. Don't wimp out and go to decimal on that. All right, problem 4. Now, there's some possibilities on a problem like 4. Like, first thing I might do is distribute, and that's a good way to do it. If this 3 and this 2 had been multiples of each other, like for example, if this would have been a 6 instead of a 2, instead of distributing, I would have chosen to multiply by the greatest common factor, okay, which would have been 3. I would have divided by the greatest common factor, which would be 3. But since 3 and 2, their greatest common factor is 1, dividing by 1 will accomplish nothing. So I'm not going to do it. So I'm going to distribute. And when I do, I'm going to get 12x minus 24. And that's going to equal to 12x minus 24. Now, I don't like having variables on both sides, so I'm going to subtract 12x. And I'm going to subtract 12x. And I'm going to get negative 24 equals negative 24. This statement is always true. That means that any number x on the real number line, anywhere on the number line, anywhere on this number line. How many numbers are on this number line? If you say 3, you can get up, pause the video, and give me 10 push-ups. There are not 3 numbers on this number line. There are an infinite number of numbers on this number line. I've shown 3, negative 1, 0, and 1. 2 is over here, and 3 is over here, and 4, and negative 1, negative 2. But what about all the numbers in between? There's a half, a third, a fourth, a fifth, a sixth, a seventh, an eighth, a ninth, 10th, 11th, a 12th, a 13th, and so on and so on and so on. There's an infinite amount of numbers on this number line. Any number on this number line works. You may call the solution to this the identity. It's an example of the identity. The equation is the same. Or you can tell me, depending if I say solve for x, you'll say x can be any real number. Or you could be really lazy and just put the real number symbol. It means all real numbers. All right, so let's see here. Problem 6. I've got variables on both sides. I'm going to take this 6x away, but I have to do the same thing over here. Oh, my variables canceled out again. I'll bet you think it's all real numbers. Here's why. Because we got 4 equals 8. Does 4 ever equal 8? Of course not. 4 never equals 8. We got a statement that is never true. 4 is never the same as 8. Therefore, this symbol means therefore in mathematical shorthand. Therefore, this problem has no solution. There is no number on the entire number line that will make this equation true. I can't pick a number and check my work. There isn't any that will work. On the previous problem, every single number that works, any number I would have put in for x, would have yielded a true response. Now, let's just refresh our memories that there are 3 things can happen when I solve an equation in one variable. 3 things can happen. The first one is so obvious that kids can't often tell me what it is. Okay, and let me put the A in equation. All right, the first thing is there might be one solution, right? Like x equals 12 or x equals 7/5. The second thing that can happen, there might be no solution, like the previous example I just did. And then the third thing that could happen is there might be infinite solutions, meaning that all those numbers on the number line actually work. Okay, going to do 2 more types of problems. Well, 1 more type, 2 more problems, solving literal equations. And these are, we're just pretending that the variable that we're not solving for are numbers. So, for example, this one says to solve for x. So x is my variable. I'm going to work to get the x alone. Well, Saddam tells me to undo addition before I undo subtraction, or excuse me, before I undo multiplication. And so I'm going to subtract by from both sides, and I'm going to end up with an a squared x. Those have canceled. That's going to equal c minus by, right? Now, x is not alone. What's keeping the x from being alone? An a squared. How are they attached? Multiplication. So I'm going to divide by a squared. I'm going to divide by a squared. These will cancel. My solution will be x equals c minus by over a squared. okay, just like their numbers. All right, number 7, I have to solve for p. Again, you can pause the video and try this on your own. So the first step will be to add d to both sides. Okay, and so I'll get SP equals Q plus D. And then I got to get P alone. S is attached by multiplication. I'll divide by S. And so I'll end up with the equation P equals Q plus D divided by S. And there you go. Simple as that. All right, I'm going to end this video now so that it doesn't get too long, and I'll make another one about the second part of Chapter 2. Mr. Lawrence signing off. Have a good night, everybody.